Welcome to our chemistry tutorial. Today we're going to be looking at balancing chemical equations using a mathematical approach. Now, in our chemistry class, most times when asked to balance the equation, it involves just putting numbers and guessing and trying to fit the numbers to ensure that they meet up with expectation. But most often than not, there is always this difficulty in trying to note where the right numbers fit. We do know how the equations come together, but we just don't know where to put the appropriate and what appropriate coefficients to put to actually make the equation balanced. And so this will actually enjoin a mathematical approach, the use of simultaneous equations and seeing how we can actually balance a chemical equation, so to speak. Just follow me on the board and let's look at how we can actually balance the chemical equation. Let's take something very simple, something you're pretty much familiar with. Let's say ethane plus oxygen to give carbon dioxide and water. Let's say this is the equation we intend to balance. Ethane plus oxygen to give carbon dioxide and water. The first thing we do in our balancing of the equation is to first and foremost insert letters as the coefficient A, B, C, and then a D. Okay? Then we do what is called coefficient balance. We do what is called coefficient balance. First and foremost, carbon. The total number of carbon on this side must be equal to the total number of carbon on this side. You have 2 times A. So basically you have A times 2. That should be equal to the total number of carbon on the other side, C times 1. This equation simplifies to 2A is equal to C. Keep that in mind as your first equation. Then you do the hydrogen balance. The hydrogen balance, A times 6, total hydrogen on this side should be equal to total hydrogen on this side. A times 6 is equal to D times 2. And essentially, you can divide both sides by 2 to make things go a bit simpler. And so we are left with D is equal to 3A. And third is oxygen. And oxygen essentially is 2 times B times 2, that's oxygen on this side, is equal to total oxygen on this side, 2 times C plus 1 times D. And so basically you have 2B is equal to 2C plus D. We could just simply make a quick substitution. C is actually 2A, so 2A, and D is actually 3A, so 3A. Hence, you have 2B is equals to 2 times 2A is 4A plus 3A. 2B essentially is equal to 7A. Divide both sides by 2, and we're left with B is equal to 7 over 2A. In order to ensure that C is a whole number, D is a whole number, and A is a whole number, the denominator here is 1, denominator here is 1, denominator here is 2. The LCM of all the denominators is 2. So let's select our A as the LCM. Let our A be 2. If A is 2, then it means that B will have to be 7 over 2 times 2. So B will have to be 7. It also further means that C will have to be 2 times 2. And so C will take on the value of 4. It also means that D will have to be what? 3 times 2. And that essentially will give us 6. So if we make the substitutions where it's supposed to be, we basically have that The balanced equation is now 2C2H6 plus 7O2 to give 4CO2 plus 6H2O. Let's check to see that it is balanced. Let's check to see that it is balanced. You have how many carbons here? 2 times 2, 4. How many carbons here? 4 times 1, 4. How many hydrogens? 2 times 6, that's 12. How many hydrogens? 6 times 2, that's still 12. How many oxygen do we have? 7 times 2, that's 14. Here we have 4 times 2, that's 8 on this side. And here we have 6 times 1, that's 6. 8 plus 6 is 14. So everything is balanced. And that's how we balance a chemical equation mathematically without having to guess. Thank you for watching the video. See you next time.